And I need to move the chat over. Just 1 second. Hold on. Chat over. Just do this. Okay. And fine. Okay, get rid of that. All righty. Welcome, everyone. This presentation, while called a climate change bootcamp, the formal name is the Mechanics of Local Carbon Reduction. This is to develop ways in which and show you ways in which you can reduce carbon in your community or in your region. And it's based upon my 40 some odd years of doing things like that and working very hard to get other people to do the same thing. Okay, now in the document, which I believe Nadja sent you, if not, we will, there are a number of items. One was a glossary, which defines all of the acronyms and things that I use. And if I forget to say which one of them is, just go ahead and chat me a question. But when you do chat, please do it in all caps. It'll make it easier for me to see on the other screen while I'm working. And in the beginning of that Word document, there were some pre-class tasks, which if you want to do them in between the class or after the class, whatever. But here's the basic idea. If you're going to try to convince people to actually go ahead and do some of the things I talk about, it's best if you tried them yourself. One of the worst things that can happen when you're trying to convince people to cut carbon is you say, you really ought to do this, or you really ought to do that. And then have one of them turn around and say, have you done it in your home? Have you done it with your car? And if you turn around and say, well, no, you kind of lose 80% of your credibility. So at some point, here's what you ought to do. Come up, if you could, especially before the next class, have 3 key questions or success barriers, things that have stopped you from being able to do the things we talk about, being able to persuade people and agencies and village boards to go ahead and reduce their carbon. You should all read my whole glossary. I know it's long, but it's very fast read. There are so many different terms and so many different agencies involved in this that the glossary is something you should keep around. If you run into a situation with it, ask me a question between now and next week. Now, when I use the term walk the walk, here's what I'm talking about. These are things you can do without having to do anything with anybody else. You can identify your home's power supply and suppliers and where it's from. You can total up your kilowatt hours, therms, and gallons just to see how much energy you're using, which is proportional to the amount of carbon that you're producing. And you can calculate your household carbon footprint. We're going to show you a place to go and do that. You can also, from that, determine the cost of carbon offsets, which is a process by which you can pay somebody else to reduce their carbon and thereby negate or at least counter the carbon you continue to produce. I also want you to think about deciding how and when you will switch to an electric vehicle if you have not done so already. And finally, you need to think about getting either audits or proposals for carbon cutting energy options on your home, or if you're in an apartment house, car, whatever. But trying to do these things on your own, to walk the walk, is one of the best ways to get the confidence and the knowledge and the perspective on how difficult some of this stuff can be and what it costs. Because much of what you heard about or read about on Facebook or whatever is not completely true. One of the things I do professionally for my clients, and they are many larger commercial industrial clients, is to tell them what makes sense and what doesn't about a lot of the climate issues. So what is that big climate issue we're all talking about? Well, many of our devices, things like cars, burn fossil fuels that create gases that trap heat in the atmosphere. The most common of these, greenhouse gases as we call them, is carbon dioxide. Now, our planet can neutralize some carbon dioxide and has done so for hundreds of millions of years, but much more of it may result in irreversible harm. We are rapidly approaching that point. Even small changes to the average world temperature, and I'm sure you all know this, but I'm just recapping it for anybody who hasn't been around for a while. Even small changes to the average world temperature can have catastrophic impacts. Deadly heat or cold waves, severe storms, flooding of coasts, riverfronts, and islands. The calculation of what we need to do to avoid that is to cut the greenhouse gases in half in the next decade. That is extremely unlikely. So I want to prepare yourself for the fact that what we're going to be doing is not saving the patient. We're going to be making the patient as comfortable as possible while we try to find ways to do this kind of thing. So if in fact you have to leave this class at some point, I'm going to give you now the executive summary of everything Lindsay has learned about this stuff in the last 40 years. Here we go. Barring any major technological breakthrough, like making batteries for EVs at 1/3 of the present cost, something like that, or hydrogen as a new replacement for methane. Barring those kinds of technological breakthroughs, there is no way to avoid the 1.5 degrees centigrade rise in world air temperature. They can talk about it all they want in Paris or Glasgow or whatever, but we're past that point. We're already at the 1.1 or 1.2 degree level. So trying to trim off that last 0.4 or 0.5 degrees is going to be a really uphill climb. That does not mean you should give up on it. It just means you should realize we're going to fail at that, and we're still going to have to push ahead. Otherwise, it'll be a lot worse. Here are my other lessons. Like politics, all greenhouse gas reduction is local. I've had people, I'm from Croton. I've had people say to me, well, Lindsay, I've heard about great things they're doing in California and in Europe and all that. I have to say to them, we're not in California. We're not in Croatia. We're in Croton. And so whatever happens locally, whatever conditions exist locally are the ones you need to focus on, because some things that are happening in California don't make sense here. Some things we do here may not make sense in Croatia. Think local. And use governments. I mean, don't just, harangue governments, but use them. Find ways to get into the processes, to expand your options and your capabilities for making things happen. And once again, I'll say it, focus. We have organizations and committees that try to do everything at once. They all feel like, oh, I must do both sustainability and I must do resilience and I must do, get rid of the straws and all the rest of that at one time. No, you want to get something done, focus. Doing everything at once is equal to doing nothing well. You have only a certain amount of resources, you got to focus them. That means you're going to seek the most results from your available resources. And to get this stuff done, there are 5 basic resources. Your personnel time, how many people you got in your committee or in your group, how much time do they have? What kind of knowledge do you have? Do you know enough about your local community's previous efforts to be able to move ahead and go beyond them? What kinds of money can you get your hands on? Grants, budgets, donations, whatever. What kind of access do you have? Do you work with somebody on the town board? Is that somebody on the town board on your committee? Can you get in front of others, other kinds of organizations to make your pitch? And finally, what kind of leverage do you have over the powers that be to get something done? We're going to talk a lot about that in the second part of our presentation next week. But these are the resources you need to develop. Without them, you're not going to get very far. And use the existing venues and tools. Don't reinvent wheels. As I'll tell you again, both in this class and next week, you don't need to create a new organization. There are plenty of organizations out there already. You want to get involved in one of them and move it to get their action together. Same thing with a lot of tools. You don't need to produce any tools. There are a lot of good tools out there. And look especially for greenhouse gas projects that also make or save money. Money is literally the coin of the realm with reducing GHG. If you can't find ways to make or save money with a project, it's got a very small chance of succeeding. Everybody wants to save the planet, but believe me, if you can say to them, I'm also going to save and make you money, you're going to get their attention right away. You're going to hold that attention. All this means that in the end, you're going to become what we call a project developer. This is somebody who finds the opportunities, a nice flat roof on a village building, totals up the benefits, how much solar it can produce, how much money it can save, and the costs to put it through. And finally, gathers the resources to make it happen. A grant, some sort of working with an agency, getting the Department of Public Works on your side, whatever. Project development is really what makes all this stuff happen. So in case you fall asleep during the rest of this presentation, that's the major points of it, and I'm going to expand on them. But now, so we have a good background before we try to do any of these things, we're first going to have a little chemistry lesson. Many of you already probably know half or 2/3 what I'm going to say, but this will fill in some blanks. There are 6 major greenhouse gases. The first 3 have the most impact due mainly to energy use. That's carbon dioxide, methane, and nitrous oxide. All of them come from either burning things or, as with methane, landfills, livestock, even producing rice produces methane. It's a basic part of the agricultural issue. Those are the big 3, the first big 3. The other 3 are used in equipment and industry. You're probably never going to get involved with them except possibly the first one, which is hydrofluorocarbons. Those are the refrigerants that are used in a lot of air conditioning systems. You don't want to leak them. If you remember one thing from this class, remember this. You have an air conditioning system in your car. If it stops working, that means it's leaking. Don't just go to a garage and have them refill the AC in refrigerant, because that means it's going to continue leaking out. As you'll see, refrigerants are one of the worst things in the world that we work with every day that can impact the climate. The other two, sulfur hexafluoride, you're never going to touch that. That's what we put in utility power transformers that replaced the old oil filled with PCBs. And perfluorocarbons, which are used to clean up electronics like circuit boards, and also a lot of industrial solvents. Each one of these six affects climate to a differing degree. In order to give a way to describe them numerically, we have something called global warming potential, or GWP. GWPs are a way to rate different greenhouse gases. GWP is essentially the impact a greenhouse gas has on global warming relative to carbon dioxide over a 100-year span. For example, carbon dioxide, by definition, has a GWP of 1.0. It lasts over 1,000 years. It still breaks down a little bit, but suffice to say, it's around forever as far as you're concerned. Methane is unusual. And let me go back to that before I forget it. Methane has a GWP of about 28 to 30, depending upon who you'll talk to, again, over a 100-year span. But it breaks down very quickly. Methane has a half-life of only 7 years, which means after 7 years, half the methane has turned into something else. After another 7 years, what's left is turned into something else, etc. So it doesn't last very long, but the remnants, it breaks down to 6 other products, which I won't bother you with because they have long names. They each also have their own GWP. That's why you can talk about methane having a GWP of 80 if you talk about only the first 20 years. In 20 years, almost all the methane is gone, but then it turns into something else. Nitrous oxide, that's terrible. That's 10 times worse than methane, but it only lasts on the order of a few hundred years or less. Hydrofluorocarbons, terrible. Not only do they have a high GWP, but they last hundreds to thousands of years. Sulfur hexafluoride, disastrous. Over 1,000 years. Perfluorocarbons, 8,000. Also with a lifetime that may vary a great deal. Now, if you want to take these numbers at GWP and actually use them, you have to know how much, usually in tons of gas of each of these types, gets released. Fortunately, of the bottom 3, which have very high GWPs, not a lot of them are released. You're talking about thousands of tons a year. Even that 1,000 tons a year doesn't have a big impact because they even with the high GWP, because it's a small amount. But huge amounts of carbon dioxide, big amounts of methane, significant amounts of nitrous oxide are released. If we had to come up with a way to look at them as to their relative impact on climate, EPA has this nice little pie chart. What you see is that, of course, burning fossil fuels, which produces carbon dioxide, that's the big kahuna. Notice in the lower corner, we say CO2e. That's the equivalent carbon dioxide. A lot of this stuff breaks down into other components. Methane, that's still a biggie. That's about 10% of the problem. Nitrous oxide, about 5%. And the fluorinated gases, those are the biggies, little teeny amount of that because they're very small quantities. And we can each take actions to reduce our emissions of these things. But there are also ways in which we can, in a low-cost manner, cut the actual impacts by other means. We talk about this later on of our renewable energy certificates and carbon offsets. None of those options are perfect. They all have flaws, but they are better than nothing. So ponder this. It's carbon dioxide primarily from the burning of things that makes the biggest difference. Methane comes up second, and then the other was nitrous oxide, and the ones with long names, small. That's one way to look at it. But now let's look at the enormity of the overall problem, putting it over a timeline. This is a chart that shows over the entire lifetime of the United States, from 1776 up to 2019, the amount of energy that is used. Now notice 1776 to 1850, not much. It's mostly wood. That's the lowest green chart that you see at the bottom. But then as we get to 1900, 1950, that's where we have discovered, if you will, coal, oil, and natural gas. Those are the blue ones. And they are the biggest bunch. They are our addiction. We've built a society that is built around and addicted to fossil fuels. It is encumbered into everything we do. Only recently, if you're going to put this out in, by comparison, has wind surpassed wood in produced BTUs. Solar has yet to do so. Yes, many of those things are being produced, but the enormity of our dependence on fossil fuels dwarfs all the rest of these things down here in green. You'll see nuclear, that's still a fairly large component, but still small compared to fossil fuels. Then all the rest of those little ones down in the lower right-hand corner, biofuels, hydroelectricity, wood, solar, they're still small by comparison. It's getting rid of those light blue guys at the top that is the big difficulty. It is going to be hard. This is not a reason to be discouraged, but it is a reality we must address. You must be aware of the enormity of the problem and avoid some of these, glad-handing Facebook people that come around and say, oh yeah, if we all just cut out eating meat, the world would be solved tomorrow. No, it would help, but it's not going to solve it. You don't eat oil. You don't eat gas. You don't eat coal. Studies and pledges about changing this are useful. What we need are immediate physical changes, things like switching to electric vehicles. Those will yield measurable results, something more than lip service. So to quantify your personal climate impact, there are ways to figure that out. Again, this is a way to get your feet wet, learn about this stuff enough by doing it for yourself first. The annual carbon impact that's attributable to a person, a family, or business, we call it a carbon footprint. It's an easy way to quantify your climate impact. Using EPA's standard carbon footprint calculator, you'll find that a family's footprint, this is like 3 people, 4 people in a family, can be at least 20 and quite possibly more metric tons, that's MT, metric tons, of CO2 per year. A metric ton is 1,000 kilograms, which comes out to be about 10% bigger than a regular ton. There's the footprint calculator that is also in the Word document that you received. The bottom line is here that determining your footprint can help you understand what causes it. It can help you find ways to reduce it, because you're going to focus in and say, gee, what causes most of it? Is it the fuel oil that I burn in my boiler? Is it the 50,000 miles a year I drive in my car, or what? Now, the point of doing all this is that it's a way to make comparisons and be able to set benchmarks for yourself. A lot of communities, a lot of countries are doing exactly that kind of thing. The Paris Accord that was passed a number of years ago is essentially an agreement to develop footprints by nation, by community, and whittle them down. The benchmark, if you will, from Paris Accord is that nations would reduce their GHG output by 26 to 28% by the year 2030 relative to 2005. That's not going to happen. We're getting closer and closer to figuring out how to do it, but still nowhere near that. But it's a way to move forward. It's to first learn how much you are contributing. Remember, if you have any questions, just send me a chat and put it in all caps so I can see it on my second screen. So how do you do all this? How do you bookkeep your carbon? To quantify your responsibility for greenhouse gases, you want to focus on what you own or control. Yes, if you eat a piece of meat, that's when you cook it, going to produce greenhouse gases. Also, somebody had to grow the meat, somebody had to feed the cattle, et cetera, et cetera. There's a limit to how far you can go back on this before you end up, in essence, taking responsibility for somebody else's greenhouse gas footprint. So let's take something simple. Let's take a washing machine. Everybody has access to a washing machine. The manufacturer, the GHG from manufacturing, that's in the factory's footprint. Isn't water a GHG? Water vapor is a mild greenhouse gas, about GWP of 1.5, but by itself, water is not a greenhouse gas. If you vaporize it, it is slightly, but 1.5, very small. It doesn't come anywhere near these other items. Just answering questions that pop up on the chat. The fuel to deliver your washing machine, that's not you, that's in the shipper's footprint, that's in his truck. But the greenhouse gas from the electricity to run it and the fuel to heat its water, if you use hot water in your washing machine, that's on you. Also, the greenhouse gases to produce the metal, unless the metal is recycled. Your town probably has some sort of a thing where it talks about every Wednesday with appointment, they'll pick up the white metal. White metal is typically appliances or things like that. We try to do as much recycling as possible so that people do not have to keep making new metal, because to make metal means you've got to dig it up. That's iron. You've got to heat it to make steel. You've got to go through all kinds of processes. Things like metals, things like concrete, use a lot of energy to be produced. So just for this typical example of a washing machine, how can we shrink our carbon footprint for that? Start out by using a highly efficient unit. Energy Star, see the little trademark? That's something that is run by EPA. That's Federal Energy, Environmental Protection Agency. They brand different things, and if it's got an Energy Star on it, it's probably one of the best ones as far as efficiency. You can, of course, wash with cold water nowadays. There's all kinds of different washing machine materials, that you can use that'll work with cold water. And you may also have an opportunity to run it on renewable power. We'll talk more about that later. But these are just examples of what you can do for something as simple as a washing machine, to understand what you do. You do not own the process to build it. You do not control the manufacturing. You do not control what kind of fuel is used by the shipper, but you do have the ability to reduce the energy used by the machine, and also as a piece of waste product to minimize the need for more of it later on by properly recycling it. It's just one example. We'll go through a bunch more later. Now, in the lingo of this process, international standards have divided the sources of GHG into what they call scopes. So whenever you hear about scope 1, scope 2, scope 3, I'm going to tell you about that now. It's not going to make a huge difference to your life or anything, but it'll help you understand how this stuff is accounted properly. Here is a graphic that has been used all over the place. See the cloud at the top? Those are the big 6. Carbon dioxide, sulfur hexafluoride, methane, etc. Each of the arrows indicates one of the scopes. So let's walk through them as they are. Scope 1, this is on-site combustion. This is the carbon you produce in your boiler, in your furnace, from running your car, if it's a gasoline-driven car. That's scope 1. It's considered direct emissions. Scope 2, which is a form of indirect emissions, is from burning something to make electric power, or if you're in the city of New York, to make utility steam, that kind of thing. Primarily for us, it's electric power. And also the line losses that occur getting that power to you. So it off the bat can be something that people don't fully understand, because they say, what, electricity? I thought that was totally clean. No, it makes carbon, it comes from making it, unless it's solar or renewable or wind or something. The vast majority of electricity is still from fossil fuels. We have a question. And also, how often you use your washer? How often you wash your linens, clothes? If you hang your laundry rather than dryer. The dryer is a different issue, but yes, if you don't, if you fill your laundry or your washing machine fully each time, it will reduce the amount of water and the amount of energy involved. Thank you very much, Anne. And yes, eventually we'll get to talk about electric dryers, if you have an electric dryer. So scope 2, that's the electricity, or the energy that's used, the greenhouse gases that come from using energy to produce the electricity. Scope 3 is how you dispose of or handle your waste of various types. Also, the products that you use, you consume, and also any paid travel. Now, the way they break these things out is kind of artificial, but this is the international standard. So when we talk about, if you take a bus, you take a train, take a plane, take a ship, that goes in scope 3, because oftentimes it's more difficult to determine and also may require more activity to figure out what the energy was that was used by the particular type of transport. But it also has to do with, how do you dispose of your wastes? So for example, something like methane in a landfill, that might fit into scope 3 because it's not being combusted, it's methane coming off directly. Those are the 3 scopes. You'll find that for your own home, most of what you're going to be responsible for is going to be scopes 1 and 2. Scope 3, you're going to find that harder to figure. There are ways to do it, but in essence, unless you are producing something, like for example, you have a home-based business, you're doing Etsy type stuff and you're buying things and putting them together and selling them, then you have a different responsibility because you're controlling the supply chain. But in general, you don't, as a homeowner or an average person, control the supply chain that brings your shoes to you, for example. So the calculation of scope 3 can be very different depending upon whether or not you're just a homeowner or apartment dweller, or if you have an actual business that consumes and produces products. So how do we have another question here. You have some control, choose to buy appliances that are made in North America. So I list GHG for transport. Again, the transportation of the washing machine, that is in the transportation, that's in the shipper. So yes, there may be less greenhouse gas for transport, but that's in the shipper's footprint, not yours. Yes, it's fine to buy things that are made in North America or in Canada or Mexico, but understand where the boundaries are of what you're doing. Let's get into scope 1. Everything has an emission factor. You can convert gallons of fossil fuels used in your boilers, your furnaces, your cars into their equivalent carbon. If you burn a gallon of number 2 fuel oil, that's 22.8 pounds. Now you may say, a gallon of oil doesn't weigh 22.8 pounds. It's about 7 pounds. Where does the other 15 pounds come from? It comes from the oxygen that is combined with the carbon when you burn it. A gallon of gasoline is about 19.4 pounds. So you may take something that weighs only 5 or 10 pounds, but when you burn it, it produces double, triple, quadruple the amount of carbon dioxide because of that chemical process. The best ways to cut scope 1, energy efficiency, conservation, insulation, ways to be able to get down the actual usage you have in ways that you have a direct control over. One of the best ways to start is what's called a home energy assessment. Years ago, we called these energy audits, but people began to think that somehow that involved the IRS. No, it doesn't. So the word assessment came along. Same thing as an energy audit. You can also use a cleaner fuel. The lady in this picture is using a condensing gas boiler. She has natural gas coming into her house, heats her hot water, heats her home, but a condensing boiler is much smaller, much more efficient. It grabs the heat from the exhaust and uses that also. That's just one example. You may also want to do something like a conversion from fuel oil to natural gas. Yes, natural gas still produces methane. It has methane, so it produces carbon dioxide, but it's about 30% less for the same BTUs, the same energy. B10 is a form of fuel oil that about 10% of it has been displaced by deglycerized soybean oil. Still not perfect, but less than a fuel oil. Up north in upstate New York, some people use wood pellet boilers. If the wood pellets can be assured to come from a fuel from forest waste and not cutting down trees, then ponder it. NYSERDA will actually give you a grant to put in a wood pellet boiler. And of course, there are heat pumps. Heat pumps are like reverse air conditioners. They're able to pull heat from the ground or from outside air, and pull that heat in, condense it, and then send it to you as hot air or hot water, depending upon your system, and use electricity to run that process. Still not zero, but a way to more effectively and more efficiently and in less greenhouse gases produce what you need to heat your home, heat your water, etc. And finally, of course, make your next car an electric vehicle or a plug-in hybrid. I'm not telling you to get rid of your car right now, but I'm saying next time you're in the market for a car, next time, give some serious thought to this. There are now 40 different models of electric vehicles or plug-in hybrids. There's something for practically everybody. Yes, they cost more. In New York State, depending upon the type of the brand you can get, you might get $2,000 back from the state. The feds may give you $7,500 off of your income tax as a credit. If the big $1.75 trillion bill passes the Congress, there's a possibility that there may be as much as another $5,000 deduction from Uncle Sam. That can kill off pretty much the entire difference in cost between an EV and a standard gasoline-driven car. I've had my Volt, which is a combination of electricity and fuel. 95% of my miles end up being run on electricity, and I have my own charger. 7 years I've been doing that. I've just been amazed at how much fuel you can save. I fill up the small tank partway in January and July. That's it. The other all-time usage of it, the other 90%, 95% of the miles run on electricity. And all my power, it comes from renewable sources. You can make a difference. Just think about next time you're going to buy a car. That's scope 1. Scope 2, this is the fuel that's burned for you to make electricity. Power plants emit that equivalent carbon, but it's different on different parts of the grid. Depending upon where you live, it can make a big difference. In California, for example, to make a kilowatt hour of electricity, you're going to emit at the power plant about 0.56, a little more than half a pound of CO2. If you're in Wyoming, gee, that's 2.1 pounds, almost 4 times as much. How could that be? It has to do with what they make electricity from. A lot of California has either hydro or nuclear or other sources, wind, solar, that are very good and have low emissions or zero emissions. In Wyoming, 80% of their electricity comes from burning coal. That's one of the worst things you can do to make electricity is burn coal. What about in our neck of the woods? Creating power in our area, and we're talking Con Edison. It's different when you go upstate, different when you go out further to the east or west. It's about 0.7 pounds per kilowatt hour. That's good. It was lower before the 2 Indian Point power plants were taken offline. And I have been an anti-nuclear advocate for over 40 years, but taking the 2 power plants offline boosted us from approximately 0.55 to approximately 0.7 pounds per kilowatt hour, because when the nuclear plants are taken out of business, they're replaced by combined cycle natural gas fired power plants, which still better than the old junky power plants, but still produce carbon dioxide. And it's important to remember that electricity is not the cleanest source. People say, oh yeah, I'm going to run everything on electricity. It'll be perfectly clean. No. Depending upon where you charge, charging an electric vehicle in Wyoming can make as much carbon dioxide equivalent as a 27 mile per gallon gasoline car. That's where most cars are now of any normal size, 25 to 30 miles per gallon. So if you're in Wyoming, it may not make a lot of sense to get an electric car because you're going to make just about as much of a mess as running it on a standard car. We have a comment here. We love our Nissan Leaf, have traveled to Boston, Philadelphia, Baltimore, Albany, Lake George, all on electricity. Very good. Glad to hear it. Glad to hear it. So scope 2 depends on where you are and how the electricity is made. And that is a moving target at this point. The way to minimize your scope 2, use Energy Star appliances, whether it's a washing machine or a dryer, especially if it's an electric dryer, use Energy Star. If you have not yet changed all your light bulbs to LED, do it. You're going to make that money back real quick, and you won't have to get up on a chair and change a lamp for probably the next 15 years. If you have air conditioning, which most of us do, consider also a ceiling fan. In many cases, even when it gets up to 80 degrees outside, running a ceiling fan may make you just as comfortable as air conditioning. Once you get above 80 degrees or it starts to get really humid, turn on the AC. But ceiling fans are very good for between outdoor temperatures of 65 to 80. Why do we say 65? Well, if it's 65 outside, add 5 or 10 degrees inside for the internal load you create with washing machines and dryers and cooking and all that. So 65 to 80 is typically where something like a ceiling fan might be very good. And in our area, there's a lot of hours between 65 and 80. Likewise, try to use renewables. Do you have rooftop solar? Many of us, myself included, cannot do it because we're surrounded by trees. But also, does your community participate in community choice aggregation? That's CCA. Most of them also participate in that program to get RECs, RECs, Renewable Energy Certificates, which, as I will describe later on, is a way to displace that kind of fossil fuel power. Let's see, Caroline tells us that her 2005 Prius gets almost 50 miles a gallon most of the time. I rarely need to drive, so I only have a bit over 100,000 miles. Very good, Caroline. Now, scope 3. This can be a little complicated, so bear with me. Some gases much worse than CO2 are emitted in small amounts as leaking refrigerants, methane from landfills, and what are called VOCs, volatile organic compounds. Those are things that vaporize off when you're using paints or thinners or sprays or even flooring. You can buy different kinds of flooring that may have low VOCs, which means they don't emit as much of it. If you have the choice of buying something that says low VOC, assuming that the manufacturer is telling the truth. Buy it with low VOC. The methane, landfills, livestock, there's some here that are very difficult to control. Most of us in Westchester don't have a landfill. I don't know how many times I've had to say to people who live in Westchester who are, especially in the southern portion, up to even the northern portion, they say, oh, we got to get rid of the landfill. And I keep telling them, we haven't had a landfill in 35 years. Have you never heard of Charles Point Incinerator? It's a good example of people who read Facebook and don't read reality of local. Incineration is not a perfect answer, but it is a significant reduction in greenhouse gases relative to landfills. Industrial solvents are also a problem. We have people sometimes who throw away old gasoline. I had a neighbor who one time said, oh, I've got this old gasoline. What do I do with it? And he dumped it into the ground in his yard. And of course, it all vaporized. The proper thing to do is you take it to the recycling facility out in Valhalla near the Westchester Medical Center, and they will take it and dispose of it properly. So what else we got in scope 3? Purchased travel. You go on a bus or a train, diesel fuel or electricity is being used to move you from point A to point B. If you fly in an airplane, jet fuel at very high altitudes, inserting that right into the atmosphere. How do we get around scope 3? A lot of different loose end efforts. First thing you want to do, control your waste. Recycle as much as possible. Many of us have required recycling in our communities. That's great. But also reuse what you can. You don't have to, if you can find some way to reuse what you got, do so. The less we make, the less we throw away, the better. Maintain what you got. Some people say to me, oh, well, I got a hole in my shoe. Go get a new sole. Go get a new heel. You may still have another 500 walking miles in that shoe. Do what you can to maintain what you've got. Properly dispose of what you've got. If you have a lot of food waste, consider composting. If you're in a situation where you have an option to incinerate something in a proper incinerator, not something like a 50-gallon drum in your backyard, that is always better than landfilling. The incinerator that is at Charles Point is of exceptional character. Yes, it makes a smell. Yes, it makes noise, but it is what we call a waste to energy system. It produces from the waste heat that comes from burning our garbage, 60 megawatts of power and thousands of pounds per hour of industrial steam that would get produced otherwise. It's about as clean as the average kilowatt hour that's produced from a mix of, well, I won't say nuclear, not anymore nuclear, natural gas and wind and solar and other things that get mushed in. It's about as clean as all the rest of that. Not a big fan, but it is much better than having things sit out there and degrade and produce methane. If you can, look for that label that says low VOCs. And nowadays, because we all use Zoom, whenever you can, don't travel, use Zoom. Significant savings of time and effort and greenhouse gases. Don't see any more questions, so we're going to move on. So how do you buy down this footprint? How do you find ways that, gee, if you can't do it on your own, how do you get it down anyway? 2 opportunities, neither of which is completely perfect, but they are the tools we have. The first one is the Renewable Energy Certificate. This is a process by which you can buy, each REC is got the responsibility and the capability to displace 1,000 kilowatt hours of fossil fuel with 1,000 kilowatt hours of renewable power. RECs, these are purchasable on a completely competitive marketplace. My numbers here are a little off now because the price has gone up since Biden was elected. All of a sudden, everybody's buying RECs and the price has gone up. Used to be, up until a few months ago, it would add about 0.5 cent to 0.7 cents per kilowatt hour. For us, that's a small number. Now it's getting close to a penny to a penny and a half. If you're buying CCA power, that cost of the RECs is built into it. Carbon offsets, a completely different market, no connection to RECs, but it has the same kind of an impact. Carbon offsets pay for projects completely unrelated to power production. For example, capping a landfill. When you cap a landfill, you cover over the whole thing with a form of impermeable layer so that the methane cannot continue to bubble up through the surface. And then you put a pipe down through the middle of it and a pump. You suck the methane out and you burn it. Yes, that produces CO2, but that pound of methane that had a GWP of 30 now becomes a pound of carbon dioxide with a GWP of 1. Merely by burning the stuff, you've cut its impact by almost 95%. So landfills that can be capped, that work that I just mentioned, the capping, the piping, the pumping and all that, that can get paid for through carbon offsets. And again, there are a variety of places, I'll list some for you in a minute, where you can go and put money in, like a voluntary carbon fee. And that money will go to these kinds of projects. Yes, there are ways to make sure it doesn't go into somebody's pocket. We'll talk about that in a minute. But these two methods, renewable energy certificates and carbon offsets, are two ways in which, once you get down to as low as you can, by doing all your own good works, you're still going to have a bunch of carbon left over, you can reduce that somewhere else aside from at your house through RECs and carbon offsets. As I said, this is very much like a voluntary carbon fee or carbon tax. You're taxing or paying for it yourself voluntarily. Someday that may change. Let's take a look at our Westchester family. These are round numbers, rounded off the nearest 1,000. Let's say they consume about 10,000 kilowatt hours a year. Let's say they burn 1,000 gallons of fuel oil, and they drive 10,000 miles a year. This is fairly common numbers for a Westchester County family. If their car only gets 20 miles a gallon, put it all together, and the sum of those three produces about 20 to 25 tons of equivalent carbon per year. You can displace that fossil fueled electricity that they use by buying RECs through a power contract. CCA, we all know what that is, right? Okay. That's a way in which you can get RECs built in. Many Westchester homes already get RECs through their CCA. If you want to counter greenhouse gas from other sources, something like the fuel oil or your gasoline, you can buy carbon offsets. There's a whole bunch of places that'll sell them to you. Sterling, Planet, TerraPass, 3E, there's a bunch of them. I use TerraPass for mine. They are all profit-making companies that go out and collect all this money from you guys, and they have projects already in the can, like a landfill capping or whatever, or a methane digester, or planting trees, or all of the above, where they will use the money from you and that will go to bankroll those projects. Now, in order to make sure this is not something that's being done in a corrupt way, there is an agency, a nonprofit called green-e.org. This is a group that verifies the impacts of renewable power and offset projects to make sure that they are not crooked, they're not fake. If it's not got a green-e.org label on it, don't buy it. But anything you get from Sterling, Planet, or TerraPass, or 3E, those are all Green-e certified. The total cost to do this, assuming you've already done the most other things to reduce your carbon impact, can be as low as $25 a month. This price may go up as the cost of RECs and offsets go up, but it's still small. It's less than $1 a day to zero out that family's carbon footprint. So when people say, oh, I can't do this, I can't do that, I say, can you afford $1 a day to try to fight climate change? $1 a day? It's a good way to guilt trip people. In essence, that's one of the ways to do it. Here's the overall bottom line. You want to find ways to cut your actual carbon footprint as best you can. Recycle, use an electric vehicle, switch to a less dirty fuel, install solar, anything you can do on your own, but you're still going to have a bunch left over. So after you've done what best you can do on your own, pay others to negate the rest. That's how you can get your climate or your carbon change footprint, your carbon footprint down as much as possible through a combination of real efforts and then using money to get this stuff done elsewhere. Ideally, all landfills should be capped right now. There should be a law that says you can't put methane into the atmosphere from a village or town or county landfill, but there is no such law. So suffice to say, we sometimes have to voluntarily pay for things that ought to be done anyway, but that's the way to make this stuff happen. So to summarize, people often say, think globally, but act locally, to which I add one more, commit personally. This is the way to develop your own personal power to make this stuff happen. here's a question you want to ask yourself. When you're about to buy a product that uses energy, that's an appliance, a car, a light bulb, ask yourself this question. If there is a different model or a different device that costs a bit more, like some Energy Star appliances, but does the same job while causing less greenhouse gases, are you gonna buy it? And what are you willing to pay to negate the remaining greenhouse gases that you're still gonna be producing? Ask yourself that question in front of a mirror. And then realize that we are the ones that have to make this stuff on the beginning on our own selves in order to show up it to others, and also to, in a more convincing way, say, yes, that stuff works because I have done it. I'm not telling you something to do something that I've never done. I've done it myself. That adds tremendous credibility and tremendous confidence to your efforts. So if you can do all that, I will say thank you very much for helping to protect our climate. And if you're looking for resources and other ways to get this stuff done, look at the glossary and the web links in the appendices that are provided to you in the Word document. And that's the end of my show.
Thank
Any
you, Lindsay.
questions?
I have to imagine that we probably do have some. I know I have a few, so I'll let others go a few. If you'd like to either unmute yourself or write it in the chat, we can read them. Whichever you prefer.
I'd like to thank you so much, if it's okay, that you're the first presentation I've heard in a long time that bothered to talk about conservation on a personal level. You know, not only just buying the electric car, but you also talked about using less energy, period. And I've been finding that hanging laundry, turning your thermostat down, like President Carter said in the 1970s. You know what I mean? This old-fashioned, stupid stuff, really reduces my energy bill is like zero. It's zero. And I live in a rental apartment, so I haven't got solar yet. I do have an electric car for which I pay nothing because most of the chargers in these municipalities are free right now to incentivize people to use them. So I encourage you all to get an electric car. You won't pay a nickel for your fuel. Our electric car, we paid nothing since we bought it because the chargers are all not charging any money. So I get a full battery for nothing, so I mean, there's an awful lot of savings that can be had by conservation. And not many people are talking about, yeah, but how can you use less? Use less. We all could. So thank you.
By the way, one thing I want to mention about electric cars, since you have one, do you use the smart charge process?
Yes. You mean so that the energy usage is charted and fed into the grid and they can keep track of it? Is that what you mean?
Smart charge is a project and it's product. If you charge off peak between midnight and 8 a.m., you get back, depends on the project and all that, up to 10 cents a kilowatt hour for that electricity. So,
yeah. My problem is I can't charge from my household because I live in an apartment. And so I can't run a cord from my house. So I have to charge in the municipal chargers, but I know what you're talking about. It's brilliant. So any of you that could get an electric car, just charge it like, 10 p.m. to 6 a.m., and you're going to get payback, right?
And every electric car comes with the ability, it's all built into the software, to have the car set as to when it wants to charge. So for example, in my car and yours, I have mine set up so that you can plug it into the charger anytime you want, but it won't start to charge until midnight, and it will shut off charging by 8 a.m. In reality, it takes only about 3.5 hours to charge on my charger, but I still get the money back on that. So it's like a night setback thermostat. You put it in, set it once and forget it, and then it's always going to work.
And Lindsay, if you keep your car charged up, especially before a big storm, you can actually use the battery from your car to charge your cell phone or, you know, maybe even your refrigerator or something, you know, they're developing that, right, Lindsay? I think you probably know about this.
Okay, somebody just asked a question to go over it again. The progress, first I'll answer you, then let's go back.
Okay.
Smart Charge is a program that is run through Con Ed. If you have an electric vehicle, you have to tell Con Ed that you have an electric vehicle, and then you sign up for this. It is zero cost to sign up. And the way it works is that they know through a device that you install in your car. It's called an L2. It's a little box about the size of a pack of cigarettes or so. It plugs into a port that exists in all cars. Doesn't exist in all trucks, but right now exists in all cars. It's the diagnostic port. It doesn't take any electricity by itself, but it has built into it, this is going to sound like Star Trek, it has built into it a form of cell phone wherein it reports back to the Smart Charge organization, which is actually in Canada, when and how much electricity you used each day. So it knows the time, and it knows also the amount. And if it's in between midnight and 8 a.m., you get money back on that. That's called Smart Charge, called Smart Charge Rewards. How do you get the money? I get mine back through Amazon, what do you call it, rewards. You can also get it back through PayPal. I got 3 or 4 different ways to do it. So you look up on Smart Charge, and you can Google on Smart Charge. You're going to find this. You'll see the various different ways to do it. So I don't want to bend your ear with this program. But to get back to where we were before, I'm sorry I missed the previous question. Suffice to say, yes, you can do all kinds of things with an electric vehicle that people don't know about, because if they don't own them, they don't look into it. Let's go on and answer other questions. I'm sorry. I don't want to dwell too much on Smart Charge.
Caroline?
Yeah, I would like to know whether this recorded program can be available for municipalities or you guys or whoever to stream to localities so other people can take advantage of it. I mean, this was just phenomenal.
Well, so Lindsay, I'd say that that's up to you. This is being recorded and you will each get it privately. And I mean, this is such, I think, an important conversation to be had somewhat in person to the extent that we can. That Lindsay, it's totally up to you as you promote this conversation that you're having, how you want it to spread and grow.
Give it away, make more people listen.
We can certainly make that happen.
Got it.
When we get to the second one, that's next week, we're going to dig into a lot more stuff more deeply, and it's much more of a boot camp than this is. This first one was primarily what you need to know to at least understand the lingo and what's going on. Next week, we're going to talk about the actual mechanics, how you actually make this stuff work on a municipal level. Other questions or comments?
Hi, I have a very old car, a very solidly built car with 214,000 miles on it, which still gets not quite, but about 28 miles to the gallon. And I have not been able to get my head around the idea of trashing that car and replacing it with an electric car. It's a 1991.
Well, so long as it keeps running, I'm not going to say anything negative. That's why I always tell people, when you buy your next car, make it an EV. I'm not going to tell you to change your car right now.
But I think the importance of cradle to cradle is often overlooked in terms of purchasing. You know, you buy a washing machine that costs maybe $350, to use your washing machine example, and maybe it'll last 5 years or 8 years, but a washing machine that costs twice that might actually last longer. Who knows? You need really specific information on every product to know their longevity, to know if you're making the right purchase.
One suggestion on your car, by the way, is when it looks like it's getting ready to go, donate it. You'll actually get a tax deduction, and this is what we do with all the cars we've had. We donate them, and they get turned into, the metal gets recycled, and you also get some benefit from it. But the best time to do that is before it's completely dead. We donated our last car, which was a 1996 Saturn, at the point that we saw the engine getting ready to go and it was going to need a valve job. Otherwise, it was in perfect condition, excellent condition. So we donated it. The company that does that gets a tax deduction, gets money for poor people, that kind of thing. And what they did was they just replaced the engine and made it usable thereafter, and thereby recycled all the metal in it. So think about donations until the thing is getting ready to, just before it craps out, pardon the expression. That's the best place to do that. And you can do things like put in donate car in Google. You'll find a dozen people who say, yeah, I'll take it off your hands. They came here to my house with a flatbed truck, We just drove it up on the flatbed. It was gone. I got a piece of paper and I got a $500 tax deduction.
Yeah, I donated my previous car.
Very good. Other questions, comments anywhere?
Well, to jump in here quickly, Helen, to your point, it is nearly impossible to go through all the information I think that you would possibly have to go through for every single option that you have, which is why understanding kind of the major points that we're going after, even if we're making somewhat imperfect decisions, but following these sort of rules that Lindsay's laid out will help us at least narrow it down. So we're in a much closer category than we started, because there is just, an incredible infinite amount of information out there. And product options.
Right. So I listened to a talk given by, what's he called? Daniel. Let me just tell you. Should know, right? Daniel Sharell. You know him?
No, but there's a million people in this business. I don't know.
Well, Daniel Sharell is a climate activist, and he has taken it upon himself to rid the US of fossil fuel usage. And he has a book out, and a friend of mine does podcasts, a village trustee actually here in Pleasantville. And he was very convincing with the idea of the acting at that level, at putting all your effort into getting rid of fossil fuels, of battling the fossil fuel industry, who are still pummeling Washington with their need to produce coal, is a far better use of your time than choosing this or that appliance or choosing an electric car. He almost said, just it's too late to worry about all that stuff. Just fight the fossil fuel industry.
Well, at some point he's going to have to get a new car too. So let's hope he does an EV. If all a person can do is go out and hang around with a sign or whatever, do that. If all they can do is ban plastic straws, do that. Do something. But there is so much to be done that just haranguing governments is I think, an insufficient step. If you don't do it also on your own personal level, there's something a little fishy about how committed you are to actually making things happen. So I give great kudos to anybody who will do anything aside from just yap. And I do say, though, that that doesn't absolve you from also being a participant. You are a participant as long as you continue to produce greenhouse gases directly or indirectly. So if you don't do that also at the same time, I'm wondering just how committed you are. Any other questions?
I'm sure he's walking the walk, actually.
Let's hope so.
Can I just say, you guys, Lindsay, that was really well said, because we have FCWC has a student network, and the students have this big debate. Is the only thing effective is governmental policy and broad stroke, structural change, or does personal change matter? And I tell them what my mother told me: every dollar you spend is a vote for the future you want. Every dollar you spend, every time you spend a dollar, you're voting for the kind of future you want. Corporations and government are watching where consumers, because we've all been brought up to be consumers, are going, right? So we do need to pay attention to our own habits. Our own habits really, really count, and they add up between all of us. So I just want to say that.
And one other thing, go ahead.
Life is not either or. Life is and you could certainly do both things at the same time. So why have to pick?
And many of these things are also going to save you money. One of the ways I got the village of Croton, and I'll brag a lot about Croton in the next session, to do things was to say, look, you got a bunch of old lights. We can put LED lights in here, and we did so for all the street lamps, all the parking lots, all that, plus all the building lighting. We have 5 buildings. We got all that done. The payback period, how fast it pays for itself, is so short. You're talking in the matter of a couple of years. And we also, in our case, got a grant to do nearly all of it for nothing, which makes the return on investment infinite. That if you look at these things, not doing it is to leave money on the table. I converted all my lights to compact fluorescence in 1979. I did all that work at, I was used to be the energy manager for Columbia University. From 1989 to 1996, I converted virtually all of the building's campus lighting. They didn't have LED at that point, to what is called T8 and electronic ballasts. I won an award for that. I won one from Con Ed of all people. And that paid for itself. They didn't have to put money out. We used the savings to pay for it. So not doing it is throwing money away. Forget all about greenhouse gases. Think about your wallet. I'm sorry. Anybody else got questions or whatever?
Lindsay, I want to touch on a point that you did, but to really just draw a little bit of more attention to it is when we are thinking locally, and we see something where our money or our credits or our efforts and the money that we're putting in to buy ourselves out of the problem that we're put ourselves into. Sometimes those projects are not always local, and that might feel wrong, but in a lot of ways, as you pointed out, in places like Wyoming, if our money is going to fix some problems out there, it's going to be a lot more effective than locally. So something like that, which might scare us off. I think we had maybe a bit more of a discussion about it when we had this conversation a few months ago, but that was really important to me, is understanding that while we are talking about locally, those efforts, if they are made in other areas, can be even more effective and impactful.
And that's where carbon offsets come in. Carbon offsets may be not even in New York. They might be in Wyoming. They might be in Brazil. There are international markets for these things where you can make the money go to where it has the most impact. And the carbon offset market, while it's profitable, while it's capitalist, it is a mechanism for making this stuff happen. And it may be out of areas that you never go to, but they are still a way to make an impact. And it's a way to use your money in a way to make more impact, sometimes far away, than you could ever do at home.
Any other questions for tonight?
Well, this is really enlightening. Thank you for
one
all of
coming
that.
through here.
Okay, we got a long question here. Let me read it out loud here. Let me see if I can scroll down. Hold on, this is a little longer here. Just a minute, I got to scroll this one down here. Hold on, give me a second. Okay, do you know anything about Bloom Energy? Yes. Natural gas energy servers. I'm not sure about that. That's a term they use. They put the word. We'll get to Bloom Energy in a second. An installation has been proposed for a business in the town of Greenberg, and the Greenberg Conservation Advisory Council, CAC, is trying to evaluate its environmental impact and consistency with New York's goal of getting away from fossil fuels. Okay, Bloom Energy is a company that makes fuel cells. Fuel cells are a non-combustion form of where you can take natural gas or hydrogen, if it's available, natural gas into a device, which chemically then breaks it down, takes the hydrogen out of the methane. Keep in mind, methane is CH4 chemically. You can break the carbon away, take the hydrogen, and use it to make electricity directly without combustion. It still produces carbon dioxide unless you are using hydrogen directly, which is a whole other area that we can get into later on. So from the standpoint of it being a user of natural gas, it is in many cases more efficient than some types of standalone power plants. Depends on the type of fuel cell that you're using, but without getting too technical, if it's the standard Bloom Energy phosphoric acid system, that's about a 40% efficiency. Combined cycle gas power plants are about 67%. That means that 67% of the energy that goes in gets turned into electricity. So from the standpoint of, is that going to fulfill New York State's goal of getting away from fossil fuels? Well, here's where you got to evaluate it. One assumes that the Bloom Energy system is going to produce local electricity, and it's going to do it at some like 40% or 45%, whatever the system is that they've got. It's still going to be using natural gas because you don't have a hydrogen marketplace right now that can provide hydrogen to go into the system. So it's still basically a natural gas fired, pardon the expression, fired form of generation. One of the big things about, without getting technical, the situation is that the federal government, I'm sorry, both federal and especially the state government was giving up until a week ago Sunday, money toward installing fuel cells in the Con Ed territory. That is changing because of something called a community credit, which stopped on October 31st. So to answer your question, basically, it's an interesting idea. It's being pushed as ways to do generation of power locally, but it is not renewable. All it is less dirty. And it may or may not still make economic sense depending upon how these state credits and federal credits have changed over the last few days or over the last few years. It's also possible that once, assuming Biden's trillions trickle down to us, that there may be enough money so that it makes it more cost effective. So the bottom line I'd say to you is, It's a step forward, but not a big step. I hope that's sufficient, Robert, to answer you. As far as the slides being available after the session, I provided a PDF of them to Nadja, and you will make them available if anybody wants a PDF.
Yeah, they'll be sent out to you along with the recording as soon as it's up.
Okay. Then there's a question here that says, hi, Ken. Yes. Oh, yes. I'm sorry. Just repeating what you just said. Sorry, I didn't look at it before.
Oh, that's fine.
Why
Any other
do-
questions? Oh,
why-
perfect.
Why do you say that the Bloom Energy system is less dirty? What does that mean?
It means that it converts fossil fuel better than a small other generator. Typically, there are different kinds of electric generation. Right in our area, about 70% of our electricity comes from burning methane, burning natural gas. If it is an old style generator as exists down in the outer boroughs of New York City, that's what's called a simple cycle generator, those old ones. They're only about 25%, maybe 30% efficient.
But they don't send energy to Westchester County.
They send it into the same grid. Understand that the whole state is broken up into what are called zones. We're not going to get heavily into this, but if you want to read about it, I wrote a book. The book is called Lowering Your Facilities Electric Rates, and it describes all this stuff. And if you Google my name or just Lindsay Audin, you'll find out all about this. But we are broken up into a dozen different zones. Long Island is a zone. Con Edison and everything in Westchester except the upper northeast corner, which is NYSEG territory, that's a zone. Then you get further up, that the zone includes the mid-Hudson. You get further up into the state or further out of the state, there are different zones.
Mhm.
And the anything that generates power in that zone will send that into its local grid, assuming that it doesn't transport it or export it elsewhere. It'll go into that grid, and it all gets mushed together. So when you generate a bit of power in the Bronx, you don't know where that kilowatt hour is going to go. So it all goes into like a big pond. Imagine this. Imagine there's a bunch of waterfalls. Each waterfall is a generator. It goes into a pond. We all then take out of the pond. So we don't know which waterfall put the water in. So yes, it's all going in. So even those generators that are really inefficient down in the Bronx or wherever, they also are part of our problem. Those are single cycle, which means that they can take in a certain amount of methane, a certain amount of natural gas, and produce a certain amount of electricity. They'll do so at an efficiency in the area of 25 to 35%, which means that 25 to 35% of the energy that goes into it comes out as electricity. Bloom Energy, fossil fuel powered fuel cells, depends on what kind. There are 3 or 4 different kinds of fuel cells. Most of the Bloom Energies that I've seen are what's called phosphoric acid, which is the least efficient fuel cell. They will take in energy and produce it at about a 40% or 45% efficiency. Big combined cycle turbines, which is what replaced Indian Point, they're about 67% efficiency, which means that they'll make more electricity for the amount of greenhouse gas they produce. Is that enough?
Yeah, I should know it. It's not the one you mentioned. And they claim it's like more like 60%.
There are, yes, the times of what we call molten salt or molten oxide. Those are more efficient. Last time I looked, and I don't follow Bloom Energy all the time, but the blooms that I saw, what they call servers, were phosphoric acid, which is 40 to 45% efficient. If they're also now making a molten oxide type, then those are 65 or 70% efficient. But usually those are only for much larger systems, like on the order of 5 or 10 megawatts. The phosphoric acid is usually for something less than 5 megawatts. So again, depends on the kind of system that's being made and talked about.
Okay. And the number that it would be compared to is the efficiency of everything Con Ed puts out or everything the whole grid is putting out?
If you want to look at it, the best way to compare these things is in the pounds of carbon dioxide equivalent that's produced for each kilowatt hour. The lower the efficiency, the higher the pounds per kilowatt hour. So something that has a 67% efficiency will produce fewer pounds per kilowatt hour than something that is only a 30% efficiency.
So if this is something that's in the town of Greenberg and they're saying this is better than, than if it was just coming off the grid because the grid uses dirty factories and all kinds of different things, is that a legitimate argument?
The answer is it may. It depends on which kind of fuel cell they're doing. but it's still, first thing I want to make sure it's clear. People have used the term fuel cell to say, oh, it's absolutely clean because it produces electricity. The answer is no, it still produces carbon dioxide.
Yeah.
The actual overall grid right now is about 0.7 pounds per kilowatt hour where we are. If the phosphoric acid system can produce power cleaner than 0.7 pounds per kilowatt hour, then it's a plus.
Mhm.
If it's greater than 0.7 pounds per kilowatt hour, it's not making things any better. I'll get one other point here. If it is possible to use the waste heat from the fuel cell, which is prodigious, in some other way, for example, to produce industrial steam or to make hot water for a laundromat or something, then the efficiency goes up because you're not throwing away so much of the energy. So I'd have to look at the specific system that they're talking about to really see if it is a net plus or net not so much.
Okay.
We have another question here. Those of us who have an extra freezer that we can get by without, we will save a lot of energy. If we hang our laundry, even sometimes, we will save a lot of energy. If we keep our thermostats moderately warm and moderately cool in the summer, we will save greenhouse gas emissions and reduce our carbon footprint significantly. Absolutely. Even something as simple as a night setback thermostat, which is really cheap. You're talking like 40, 50 bucks. You'll turn down the heat automatically based on your schedule. If, for example, you work away from the home, during half the day when you're not there, you don't have to keep it at 70 degrees. Let it go down to 62 or 63. And then before you come home, it'll automatically, based on your schedule, turn it back up to 68, 69, 70, whatever you want. Likewise at night, my thermostat turns the heat down, like at around midnight, makes it cooler, doesn't use as much fuel, and then brings it back up again at 6:30 in the morning. And it doesn't cost you anything. It's just a little device you plug in and replace your existing thermostat. It will control that automatically. Anybody else got a question, comment, or anything else they want to say? Oh, we got another one. Bloom Energy is proposing to use a proprietary solid oxide fuel cell technology. If it is the solid oxide, that is the more efficient type. That might be 67% efficient. So that's better than the phosphoric acid. Again, I'd want to see the exact specs, and don't send it to me. This is the stuff I do professionally. Get somebody else to actually go through it. But suffice to say that if it's a solid oxide, and especially if its heat is used in some useful way, it could be a significant improvement over the standard power you get from Con Ed.
Yeah, I think the heat is not being used, and we're wondering if the heat is environmentally a bad thing for Greenberg.
Well,
we've asked them to quantify how much heat, and we don't, we're not engineers, so we don't.
the more
quantified it yet.
If you can use the heat in any kind of way that displaces fossil fuel that would provide the same heat,
Yeah.
like let's say, for example, it goes into I'm making this up. Let's say it goes to the nearby Department of Public Works, which of course has a big garage and that has to be kept warm. If you can cycle the heat there through circulating hot water, forced air, whatever, then that displaces the fuel that would be used to heat that garage. And then it becomes a better net plus.
Okay, thanks.
All right. One last note for myself. I don't know how many people this applies to here, but as a renter, I really enjoy listening to a list of things that I can actually do because so many of these other options are not yet available to me. But basically everything that we've talked about today is something that I can implement immediately, which is appreciated.
And let's keep in mind CCA, community choice aggregation. You can do that from your apartment.
Exactly.
And thereby neutralize your scope 2 emissions.
Exactly. And of course, I think of the students that we work with over at FCWC, and that is something that's available to them as well. All right. Well, on that note, I look forward to seeing everyone next week. If you found this valuable and you want to invite some other people, you can have them register still. It will be open through next week, and I'll make sure to get that PDF so that they have access to the same glossary as you all have in your possession. I know that next week we'll be going through some more of the specifics and numbers of projects that Lindsay has overseen in Croton, which were quite impressive and interesting the last time I heard them. So Lindsay, unless you have anything else to add, thank you so much for today.
Thank you all for coming and surviving through the whole class.
We'll see you all next week.
Very good then. Good night.
Good night.
Thank you. Wonderful, wonderful, very valuable evening.